Hey guys, so last time we did our goodness of fit question. This time we're going to take a look at our HOP test for chi-squares. So if we look at question number 2, that's a chi-square test for homogeneity of proportions. So there's an article in the American Medical Association Journal reported that the results of a study to see if our herb St. John's wort is effective in treating moderately severe cases of depression. The study involved 338 subjects who were being treated for major depression. The subjects were randomly assigned to receive one of 3 treatments. So that's our clue. There's one group, right? And they're randomly assigned to these different treatment groups: St. John's wort, Zoloft, or placebo. Now we have 3 different treatments. So if we have 3 different treatments and we're only measuring their response, that's our one variable. So like here is our variable that we're measuring. It's just like their response. They do have 3 different categories that they could have responded, and we have 3 different treatments. So because there's 3 different treatments, we want to see if the proportions of each one of these is the same. Okay. So our HO, our null hypothesis, is based on that. The proportion of effective responses to that depression medication is the same for each treatment group. There's probably another way to say that, but like here we're saying like there's no difference, right? In how they respond to the different drugs. Our HA is that there is a difference. So if we can conclude in favor of HA, it would be like St. John's wort works differently than Zoloft or the placebo, right? All right, our conditions. Our first condition is randomness. They were randomly assigned to treatment groups. It was a well-designed experiment. If you accidentally said random condition was met because they randomly selected, that's wrong. They said that they were using a study of like people who were being treated. So these are most likely volunteers. All right. For independence, should one person's response to the drug affect other people's? Okay, my depression shouldn't affect your depression, right? Large counts. Let's go back and check. So remember, for this one, in order to find the expected amount, you have to do the row total, well, that's the column total, the row total times the column total and divide by your sample size. So if you go through and multiply 91 times 113 and divide by 338, you would get an expected count of 30.42. 113 times 55 divided by your total, you would get an expected of 18.39. Our expected for no response taking the St. John's wort, 64.19. I think if I can read my own handwriting. The next one, we would do 109 times 91 and divide by 338. So if I just fill in these expected counts, double check that you can get these same ones. And then if you want to, start putting in your matrix A, all of our original observed data into matrix A, and then we're going to put all of these expected counts into matrix B. Okay, so it's like math, edit, matrix A. Size of matrix. Pardon. Okay, and then matrix A is a 3 by 3. And then put all of those observed. Okay, and then in matrix B, it's also 3 by 3. Put all of our expected counts. Okay. All of our expected counts were greater than 5. We're going to do our chi-squared test. And again, this should be our homogeneity of proportions or HOP test. They didn't state an alpha level, so I'm going to go with 5%. So 5% significance. We need to figure out degrees of freedom. It would be the rows minus 1. So since it's a 3 by 3, I'm going to do 2 by 2. Row minus 1, column minus 1, multiply those together. Our degrees of freedom for this problem should be 4. For the chi-squared test statistic, try to say that fast, you would calculate O minus E squared divided by E. O minus E squared divided by E, or use your calculator and just show the work like I did with the little ellipses. I got 87, no I didn't, I got 8.1, 8.719. All right. For our p-value, probability that we would see a chi-squared that high or higher is the probability under that curve. I got 0.0685. All right. We're going to compare our p-value. Oh, what'd I do? Let's try to undo that. We're going to compare our p-value to our alpha value and decide whether to reject or fail to reject. Since our p-value of 0.0685 is greater than alpha, at that 5% level, we would fail to reject our null hypothesis. And if we fail to reject this, we don't have evidence that there is a difference. So it's like, it doesn't matter if you're taking the all-natural St. John's wort or if you're taking Zoloft or you're taking a placebo. We don't see a different response to that depression. Okay. Okay. So make sure you do have that ha in conclusion and context. I tried, right? So this is saying we don't have enough evidence to support the fact that, taking these different drugs causes or changes that effective response in treating their depression. Okay.